Hello everyone. Today I will show the design of isolated footing. Okay, let's start. Here is a question. Design the suitable rectangular isolated footing of 12 into 18 RC column, 12 by 18 RC column on A, and the column carrying dead load 19 kg and live load 53.5 kg, and both F prime C 3 KSI with F prime C 3 KSI and Fy 60 KSI, and the soil bearing capacity is given 2 KSF at 5 feet below from the ground. Here is the question, so let's start how to solve it. So at first we will assume the unit weight of soil, as you know, 125 psf, but it can vary 120 or 115 psf, but we will assume 125 psf as it is. Now the overburden pressure of soil would be d into d df into gamma square. Here is d is the depth of footing, has a 5 feet depth. We have shown here the 5 feet below the ground level. That's why we have used 5 feet, and 125 is unit weight of soil, and we have found 625 psi. The bearing pressure of the soil would be the soil bearing capacity minus overburden pressure, which we have evacuated or extract or cutting this soil from when constructing the footing. That's why we will deduct from this value, and we have found 1.375 ks, and the area of footing will be unfactored. Unfactored means only dead load plus live load divided by soil bearing capacity, and found 104.4 feet square. This is the area of footing, which is means at 12 feet by 8 feet. So our length of footing 12 feet, and breadth of footing 8 feet. This is our dimension, and ultimately soil bearing capacity would be factor load. Factor load means 1.2 dead load and plus 1.6 live load, and divided by footing area L into B, and found 2.2 kg per feet square. This is the soil bearing soil upward pressure. Sorry, it will be soil upward pressure. Okay, so we will see the unit weight or unit pressure of the soil along L direction, which will be upward pressure of soil into B. When we will calculate L direction, then we will multiply B. When we will calculation B direction, and we will multiply L, and the unit pressure will be 16.16 kg per feet and 20.24 kg per feet L and B direction respectively. So we can see here the footing here the length is 12 feet and breadth is 8 feet, and L direction unit weight of pressure of soil 16.16 is along L direction, and similarly Y direction. Now we can draw the SFD. SFD means shear force diagram and bending moment diagram from this load, or we can calculate directly moment from this formula. So which one you will prefer, this is your choice. So I will show the now I will show the direct formula. So we can see this pressure or this footing will create it in like this portion is like act like the cantilever. This portion is the cantilever portion in the footing, so that's why we will use the cantilever portion WL square by 2, but we will deduct the column dimension, but column dimension divided by 2 as we calculate from center. That's why we will use this, the moment will be found at the face of the column. So ML will be WL into L by 2 minus C by 2. On the other hand, here is we call C1, C2. C1 was there is a two phase in column. We have already shown here a 12 by 18. Here is the C1 is 12 and C2 18, or C1 18, C2 12. This is doesn't matter. So so we have found this. We will set this value for deducting, and this formula only for cantilever. We earlier explain why we will use this. So W ml equal to WL by 2 minus CL by 2 square divided by 2, and found the value 222.7 kip per feet. In the same way, we have used MP in the P direction. Here is the P direction, and here is the S direction. So we have found the B direction moment, W B by 2 into C by 2 divided by 2, and found 148.5 kip per feet. So this is our moment. The moment will be needed when we will finding the reinforcement along L direction and along B direction. Okay, so before we going to design, we have to check two for sharing. One is punching shear, another is flexural shear. So let's talk about punching shear. The punching shear is occurred within d distance from column face. Here is a column face, and the punching shear would be d distance. There is a it will be occurred in d by 2 distance. Punching shear will be occurred d by 2 distance. Here is the column face, and the d by 2 is here. Okay, so we can see the column C is that column, and d by 2 distance in the left side, and on the other hand in the same way we have taken the left side is d by 2 distance. So total length will be here is C by d. In we can call it C1 by d. In on the other hand, we have taken the same value from here. We have shown that this is C, but we call C2, and here is d by 2, and here is 2 by 2. So 2 d by 2 means C plus d. Half d means full d. So here is the d by 2. So we can see the punching shear force is Q, ultimate soil pressure, into L into D. L into D means the area of footing, and we will deduct the total value, and we will deduct the this area, punching area. The punching area would be C by, sorry, this will be not punching area, this will be C by C1 plus D and C2 plus D. So we have got the value. Here is the we have we want to say that here the value of 2.2 we have dividing 12 square, because the value we have found K 2.2 kip per feet square. Now we have to convert this kip per inch square. Kip per inch square for getting the depth of footing is inch. That's why we have converting this value kip per inch square, and we have divided by 12 square. In the same way, the footing L 12 feet, and we have multiplied 12, and breadth is 8 feet and multiply 8. I have forgotten to writing here, or that's why I have written in the upper of the value, and minus C1D. C1D is the footing first face C1, and D we will find, and C2 is another side of the footing. That's why we denote C plus D, and we have found this formula, and the unknown factor of value is D. So let's we have calculate the AP. AP means area of perimeter. The area of perimeter will be this portion. I have if I changing the color, this portion will be area of perimeter. The at first we will calculate the area perimeter length, and we will multiply it. That's we will then we will find the area of perimeter. So at first we will see by 2. I will clarify why we will use 2. C1 plus D, this is the C1 plus D, this portion, and C2 plus D and C2 plus D, here this portion, and in the same way we will go to C1 plus D and C plus D. That's why we will multiply 2. And D will be the perimeter depth, or depth of footing, sorry, it will be depth of footing. That's why we will use this. If the column distance will be same, then we will use in the same value 4 into C plus D, 4 into C plus D into D, as the column dimension will be same. But if we had 4 means the 4 side, 1 2 3 4 side, but we have found here the 2 dimension of the column. That's why we have used C1 plus D plus C2 plus D. If we found the same column size 12 or 12 or 18, that we have used 4 C plus D into D. That will be our epi or perimeter of column. Okay, let's just another formula which is resisting perimeter shear force, which is 4 into 5 into root over F and C to AP we have calculated here. 4 into 5.85 F and C to 300, and we have divide by 1000, because we have converting this value to inches. Because we have in equation 1 we have all the values have taken inches. Okay, let's AP 2, here is the value 2 into 18 plus D plus 12 plus D into D. Okay, and found this the equation 2. So we have, now we can say that AP 5P into BP equal to 5P, or equation 1 equal to equation 2. Then we have set this to equation 1 and equation 2 left and right side, and calculating, and found the depth is 17.05 inches square, sorry, 17.50 inch. So it has found from the punching shear. Then we have checked the another flexural shear, or it can say one way shear. What you will call is your opinion, or your desire. So at first we have to understand that the phenomena of the footing. Here is the footing, the length of L is here, and length of B is here. So the flexural shear or one-way shear will be occurred from distance of D from a face of the footing. I want to notice that the actual very important note that the flexural shear occurred the distance of D from face of the footing. On the other hand, we have shown the punching shear. Punching shear always will be occurred within D by 2. Here is the face, here is the column, and face D by 2. So this is the very important. D by 2 is left side and D by 2 right side, or D by 2 upper side and D by 2 lower side. That's a very important. So for punching shear will be D by 2, and when we calculate a flexural shear, there it will be after the D by 2. So let's start. Here is a D, and we have if we calculate from center of the column, then C by 2 plus D, then will be the flexural shear will be occurred C by 2 into D distance. But so let's see the calculation, how we will calculate this value. D by 2 is here, and WL we have already calculated the uniform load WL, and B by 2, here is the value of B by 2, but we have deduct the value of C plus D. Here is the value of we have shown WL, we have uniform unit weight of soil. So the unit weight of in and direction of soil pressure, L direction, and B by 2, here is a B by 2, and deduct this value from center of the column, which is C by 2 in plus D. So we have deduct this value and found this strip. So WL divided by 12 means we have converting this value in keep feet to keep inch. That's why we have dividing 12. And similarly the breadth of footing is 18 and divided by 2, and C the column dimension and plus D, and we are putting this value and denoted the equation 3. In the same way, the capacity of flexible capacity 2 into 5 root over reference B into D, here is B is 8 feet, which is multiplied by 12, the converting for inches, and find the 7.88.7 into D, which all values. So here is the we have found 7.88 into D, all values are inches, and we have put the equation left side is equation 3 and right side in equation 4, and we have found the value of D is 6.112 inches square. So depth of footing is we have found 17.65 inches square from punching shear, and another is depth in footing is 6.1 2 inches square from flexible footing. So we have used the 7.1 inches for taking a safe zone as a structural engineer. So we will use the more bigger value for taking safe zone. Okay. So reinforcement in L direction. L direction means here is the L direction, which is 12 feet. So S equal to ML. ML means moment of long direction, phi FYD minus A by 2, and putting this value and found 3.127. One thing that is we have trial many of time. So the value of S equal to S FY 0.885 F prime C into B. The value will be A, and we have give the many trial, then we will get the value of A and putting this value. On the other hand, we can calculate this value in the calculator, scientific calculator. We just use this here is answer, ANS answer, and putting all value, and here will be answer, and clicking the equal and equal again and again and again until the change the value, and we will get the value will be 3.12 inches square. So this is the short form. You can use this, or you can try this. Another formula we have found is I must say that Dr. Iftikhar Anam sir, which is reputed professor in University of Asia Pacific. I must respect him. Okay, so the value and the formula is taken from her lecture book. His lecture book, but the S equal to 0.85 FMC FY1 minus root over 1 minus 2 into moment divided by 5 0.85 FMC B into D square. Here is the B. We have to take in note that when we calculate the direction L, then we will use the B. On the other hand, when we will calculate the B direction reinforcement, we will use L. Here is the 12 feet. So let's we will use this B, and we will put this all value and found 2.97 inches square. So at first we have found 3.21 inches square, and we have found the 2.97 inches square. As the another formula from as minimum. So as minimum is 2 value, which is 3 root over FMC B into D, and 200 root over FMC B into D, and putting this value and found the two value are 4.47 inches square, and on the other hand we have shown the left side in 5.4 inches square. So we have we'll take the more value for as minimum, which is 5.44 inches square. So we have conclude, if we want to conclude that the reinforcement in L direction is 1, is the equation 1, and here is the equation 2, here is the equation 3, you can say. And all of three values we have taken only maximum value. If we denote the red color, at first we have found 3.12 inch square, and another one 2.97 inch square, another is 5.44 inch square. So of three, we will take the more value of three value. So we have used 5.44 inch square for as a more value. Okay, so now we will using number 7 bar, the area of 7 bar, pi by 4 L by 4 into L by 7 by 8 inch square, which is 0.60 inch square, and number of required is S, which is found from S, and divided by S, which number of we have used, and found 9.07, which is similar to the 10 number of 10 bar we have used in the along the L direction. So spacing will be bar as equal to B. Here is a note that the B we have used when you found the value of L direction. On the other hand, when you will use the B direction, we have used here is the L. So the value will be B is 8 feet into 12, and as 0.60, and bigger as in 5.44, and we have found the 10.58 inch square center by center. So we have concluded that this is our final value of L direction. Number 10 number bar, number of 10 nodes of bar, 7 number bar at the rate of 10.59 inch square center to center at perpendicular to B. So here is our reinforcement detailing here. So now we will show the reinforcement in B direction. Here is the B direction. So S equal to MB divided by phi Fy d minus A by 2. We will put all these value, and the A will be as Fy 0.8 times this formula, but we will not use this formula because we will use this A equal to, we just put the answer in our scientific calculator and put again and again equal until the change the value, and we will found the 2.07 inch square. And the same way as equal to 0.85 FMC Fy. Here is the when we found the B, then we will use the moment value of P direction. Now if we want to go the previous slide, so we have found the two moment is L direction and B direction. Now we will calculate B direction as we have completed in M direction. So we have put all this value and found the 1.91 inch square. At first we have found 2.007, and another we have found 1.09 inch square. And in the same way we have used minimum reinforcement. Here we have used L as we have calculating B direction in B direction. Sorry. So that's why we will use the L and F prime C into L into D, and we have found 8.01 inch square. So we have taken these values more. So at we have F. Now we will summarize that. At first number 1 we have found 2.07 inches square, and number 2 we have found 1.96 inches square, and number 3 we have found 8.166 square. So we will use 6.16 inches square of the three values as the measure value. We have found 6.16 inches square in the B direction. So let's start in the same. We have using same number 7 bar as the and the area will be 7 number bar 0.6 inches square, and number of bar required will be S divided by S, which is 13, or will 13.6, but we will use the 14 bar. And spacing will be as equal to L. Here is the L. So note that I once again notice that here will be we will use the L value because we have calculating in B direction. When we calculating B direction, we have used L, all the throw value on the throw formulas. When we will calculate the L direction, we will use BB. Okay, so spacing will be 10.59 inches square. So here is our final result, which uh, 14 number 7 bar at the rate of 10.5 inches square center by center perpendicular to L. Here is our reinforcement detailing. Here we have used 14 bars, and the bars with the spacing will be 10.5 inches square center by center. The final detailing, if we want to draw from this footing, the dead load was 19 kp and live load 50.3 and FMC was 3 ksa and soil bearing capacity 2 ksa, and our footing dimension was of 8 feet and length was 12 feet, and depth we have found 70 inches square. Here is our detailing 10 number 7 bar at the rate of 10.5 inches square center to center perpendicular to, and number 7 bar at the rate of 10.59 inches square perpendicular to L. So we have shown that the two values are very similar, but in the practical field we have used 10 inches square center by center as we have staying and at the safe zone. So today's lecture is here. If you have any question, then comment here or mail me. I will try to convince you. If I will summarize that, here is the punching shear will be calculate the d by 2. This is the important, and the flexural shear will be calculated in d. And another was when we calculate the reinforcement L direction, we will use the b value all through, and on the other hand, when we will calculate the reinforcement in b direction, then we will use all the value of L. Here is L, here is L, and the final detailing is here. So thank you all.